This lesson is on transformations of exponential functions. So we learned about exponential functions yesterday, or a couple days ago. Let me grab my answer key here. And an exponential function has f of x is some number b to the x power. And so in this case, our variable is our exponent, so that is what's changing. And now we're going to look at what if we take those, this parent function here and we do some transformations to it. Alright, so first of all, what I wanted you guys to do is I wanted you to write down what the parent function is. It's f of x equals b to the x power. Just because later in the problem they're going to be asking what the parent function is for everything. Then if you look at the transformations, so a transformed function, you have b to the x power, okay, but then there's some transformations with the exponent, there's some transformations with the coefficient in front of the exponent, and there's some transformations with the vertical height of the function, that's the k. Alright, so when we look at, there's kind of a lag with my document camera and my dossary here. H is the horizontal shift. Okay, when you add something to it, that shifts the cells left. That shifts your function left. If you subtract, if it's x minus some number, that's shifting things to the right. K is the vertical shift, and that's whether or not the function goes up or down. The height of the function goes up or down. If A, which is the coefficient in front, is a negative number, then the function is a reflection across the x-axis. If A is greater than 1, that represents a vertical stretch. If A is less than 1 but still bigger than 0, it represents a vertical compression, so the function gets kind of squished together. Notice we have greater than 1 and we have less than 1. If A is equal to 1, then that doesn't change anything unless it's negative. Okay, so it doesn't change the shape of it at all if it's 1, positive or negative, other than the reflection piece. Okay, so for the next part, it says to A, identify the parent function, and B, describe the transformations. So if we have 3 to the x power plus 5, our parent function is 3 to the x. So our parent function is always just going to be some base. It's either going to be a fraction or a whole number to the x power. And the transformation is this one shifts up 5. For the next one, right here, this is our b, or our base, is the 1/4. So our parent function is 1/4 to the x power. And this is being multiplied by 2. 2 is greater than 1, so that's a vertical stretch times 2. And it's being shifted to the right, 1 value. So go ahead and try 3 and 4. Pause the video if you need to. I'm going to display the answers in a second. Okay, so those are the transformations for number 3. Parent function is 4/3 to the x power. It shifted up 7, left 2, and because it's negative, it reflected across the x-axis. For number 4, check your work. Parent function is 5 to the x power. It's being multiplied by a number less than 1, so that's a compression by 1/2. It shifted right 4, and it shifted down 2. To do the graphing, here's what we're going to do. So the first thing I want you to do is I want you to make a table of the parent function. So if we have 2 to the x plus 5, boy, this is laggy, sorry. I'm going to zoom out a little bit. 2 to the x plus 5, then our parent function is just 2 to the x. So what I did was I made a table of 2 to the x power. Then I did the transformation, and here's what I did. Whenever you change the exponent, okay, so like x and x plus 5, you're going to want to use different values for x. So think about it. If you have negative 7 plus 5, negative 7 plus 5 is negative 2. I know what that value is. It's 25/100ths. Negative 6 plus 5 is negative 1. So 2 to the negative 1 power is 1/2. That's why I shifted these numbers. When I graph it, notice that it has been shifted to the left 5 spaces compared to the original. All right, hopefully that's enough to go on. Ask me if you have any questions.